Hi friends, in the continuation of data science interview question answer series, we are moving to question linear regression versus logistic regression. Linear regression is a supervised regression model. Logistic regression is supervised classification model. In linear regression, we predict the value by an integer number. In logistic regression, we predict value by 1 or 0. In linear regression, no activation function is used. In logistic regression, activation function is used to convert a linear regression equation to logistic regression equation. Logistic regression, no threshold value is needed. Logistic regression, threshold value is added. Linear regression, we calculate root mean square error RMSE to predict the next weight value. In logistic regression, we use precision to predict the next weight value. In linear regression, dependent variable should be numeric and the response variable is continuous to value. Logistic regression, the dependent variable consists of only two categories. Logistic regression estimates the odds outcome of dependent variable given a set of quantities, quantitative or categorical independent variables. Moving question, linear regression. It is based on the least square estimate. Logistic regression is based on maximum likelihood estimation. Linear regression, when we plot the training dataset, a straight line can be drawn that touches maximum plots. In logistic regression, any changes in coefficient lead to a change in both the direction and steepness of logistic function. It means positive slope result in an S-shaped curve and negative slope results in Z-shaped curve. Logistic regression is used to estimate the dependent variable in case of changes in independent variable, for example, predict the price of houses, whereas logistic regression is used to calculate the probability of an event, for example, classifying if tissue is benign or malignant. Moving to question, decision tree versus random forest. A decision tree is like tree-like model of decision along with possible outcomes in diagram. Random forest, a classification algorithm consisting of many decision trees combined to get more accurate result as compared to a single tree. There is always a scope of overfitting causes due to the presence of variance. Random forest algorithm avoids and prevent overfitting by using multiple trees. The results are not accurate in decision tree, but in random forest gives accurate and precise result. Decision tree requires low computation, thus reducing time to implement and carry low accuracy. Random forest, this consumes more computation. The process of generation and analyzing it time consuming. Decision tree is easy to visualize. The only task is to fit the decision tree model. Random forest has complex visualization as it determines the pattern behind the data. Moving question. K-means clustering versus hierarchical clustering. K-means using a pre-specified number of clusters. The method assigned records to each cluster to find the mutually exclusive cluster of spherical shape based on distance. Hierarchical clustering method can be either divisive or agglomerative. K-means clustering needed advanced knowledge of K, that is number of cluster one want to divide your data. In hierarchical clustering, one can stop at any number of clusters one find appropriate by interpreting the dendrogram. One can, in K-means, We can use median or mean as a cluster center to represent each cluster. In hierarchical clustering, algorithm method begin with n clusters and sequentially combines similar cluster until only one cluster is obtained. K-means methods used are normally less computationally intensive and are suited with low, very large dataset. Hierarchical clustering divisive method work in opposite direction, beginning with one cluster that includes all the records, and hierarchical methods are especially useful when the target is to arrange the clusters into natural hierarchy. In k-means clustering, since one start with random choice of clusters, the result produced by running the algorithm many times may differ. In hierarchical clustering, results are reproducible in hierarchical clustering. K- In k-means clustering, a simple and division of the set of data objects into non-overlapping subset clusters such that each data object is in exactly one subset. A hierarchical clustering is set of nested clusters that are arranged as a tree. K-means clustering is found to work well when the structure of cluster is hyperspherical like circle in 2D, sphere in 3D. Hierarchical clustering don't work as well as K-means when the shape of cluster is hyperspherical. Advantage of K-means coverage is guaranteed, specialized to clusters of different size and shape. Hierarchical clustering advantage ease of handling of any form of similarity or distance. Hierarchical clustering consequently applicability to any attributes types. Disadvantage of K-means clustering: K value is difficult to predict, don't work well with global clusters. Hierarchical clustering disadvantage: hierarchical clustering requires the computation and storage of an n into n distance matrix for very large data set. This can be expensive and slow. Please like and subscribe the channel. Thank you.